Hello guys, in the last lecture, we learned precision and recall. But now the question is, do we want to deal with two numbers every time we want to evaluate our model? Actually, it's much easier if you had only one score. So how do we combine precision and recall into one score? The answer is F1 score. F1 score is the harmonic mean between precision and recall. The range for F1 score is between 0 and 1. It tells you how precise your classifier is, or how many instances it classifies correctly, as well as how robust is your classifier. And that means if it misses a significant number of instances or not. A system with high recall but low precision retains many results, but most of its predictions are incorrect. And a system with high precision but low recall is just the opposite, retaining a very few results, but most of them are correct. An ideal system with high precision and high recall will retain many results, with all results labeled correctly. The greater the F1 score, the better the performance of your model. Mathematically, F1 score can be expressed by multiplying precision and recall and dividing the result on the sum of precision and recall, and multiplying the result with 2. So a model does well in F1 score if the positive predicted are actually positives, which mean high precision, and doesn't miss out on positives and predict them as negative, which mean high recall. F1 score tries to find the balance between precision and recall, but one drawback is that both precision and recall are given equal importance, due to which, according to our application, we may need one higher than the other. And F1 score may not be the exact metric for it, and the solution is to use Fbeta-score. So what is Fbeta-score? Well, there are situations for which a data scientist would like to give a percentage more importance to either precision or recall. Altering the F1 score equation, we can include an adjustable parameter beta for this purpose. We get the Fbeta-score equation as shown in this picture. We can see how we can control Fbeta-score using the beta parameter. Fbeta measures the effectiveness of a model with respect to a user who attaches beta times as much importance to recall or precision. In this code, we will compare precision, recall, and F1 score between logistic regression and dummy classifier. Although the two models has 99% accuracy, we see how logistic regression model has 69% precision and 60% recall and 64% F1 score. But dummy classifier has 0% for all of them. Now let's print the classification report for both models. Classification report gives a detailed report explaining the precision, recall, F1 score, and support for each class we have. Support is the number of occurrences of each class in the actual labels. In our example, we have two classes, fraud and not fraud. We see that logistic regression gained perfect score for the not fraud class, and 69% precision, 60% recall, and 65% F1 score for the fraud class, while dummy classifier also gained perfect score for the not fraud class, because he always predicted every instance as not fraud, but he has 0% in precision, recall, and F1 score for the fraud class, and that's because he never predicted any instance as a fraud. We said before that in our example, we want to gain higher recall because false positives, which are normal transactions that are flagged as possible fraud, are more acceptable than false negatives, which are fraud transactions that are not detected. So let's now print the Fbeta score. The beta parameter in Fbeta score determines the importance of recall in the combined score. If beta is less than 1, then we lend more importance to precision, but if beta is bigger than 1, then Fbeta will favor recall. Now when we set Fbeta to 2, we get Fbeta-score equals to 81%. And when we set beta to 1, we get Fbeta-score equals to 82%. Now let's try to manipulate our precision and recall by setting a threshold. The threshold takes values between 0.1 and 0.9. We see now how higher threshold make us get higher precision but lower recall. So we can control the model precision and recall by setting a threshold. Okay, so that's it for today's video, and see you on the next one.